Hello everybody, welcome back to another session of DS for HS. Today we're going to talk about analyzing data in columns as numpy arrays rather than rows. So instead of doing it row by row basis, we're going to do column by column basis. Now, in this Jupyter notebook, we're going to examine and look at the benefits and values of analyzing data in columns as numpy arrays rather than in rows. Now, what numpy is a data science library, and it's going to be very, very important in your data science careers. So it's called the NumPy library, and we'll see why it's so important later in this notebook. Now we're going to start by importing CSV data using the Python CSV module with its csv.reader method. Now this will convert the CSV file into a list of strings, and you'll see that later on. Now secondly, we're going to import the exact same data, so it's going to be the exact same data using the Berkeley Data Science Library. And what we're going to do is we're going to see that exact same CSV data and how it will be converted into a table of NumPy columns, all sharing a common index number. And it's okay if it doesn't sound, or if it doesn't make sense now or doesn't sound rational now, it will later on. Just stick with it. Now, let's make this theory come alive with hands-on learning. Let's also start with using the same function we defined in our part 3 importing CSV files. So what we're going to do is import CSV here. So import CSV, and then we're going to make a function. So we're defining the function. The function is called load CSV file. It takes one argument, file name, and then we're going to have it open the file name, and then we're going to have it read the file, and then we're going to have it return it as a list. So let's do it here. We're going to assign this file to the name file, and then we're going to plug it into this function right here, and then assign it to the variable row by row, and then call that variable row by row, and let's see what it does. So as you can see from the square brackets here, square bracket, square bracket, so there's two square bracket, one on either end, so that shows us it's a list. And then there's inside of these square brackets is more square brackets, so it's a list of lists. And then inside of the subset of square brackets we see the string, so it's a list of strings, and it shows us all the credit card transaction data. Now, as you can see, the csv.reader method converted the CSV file into a list of strings, but that's because of the function we created, but inside the function we had the csv.reader method. Now, what we're going to do right here is, let me comment out these bad boys, okay, is we're going to do row by row, so the name, so this right here, this is row by row, and we're going to do index number blank colon 5. So what that's saying is we're starting at the very first index and going all the way but not including 5. So since we index from 0, it's going to include the first 5 elements. So index with the elements with index numbers 0, 1, 2, 3, 4. So if we see that, it should give us, let's see what it gives us. Shift enter. Boom. And it gives us the first 5 lists in this list of lists. So this list right here, this list right here, this list right here, this list right here, this list right here. So it returns us the first 5 lists. Now let's go here. Now what this is going to do is going to give us the last 5 lists, because it's saying, or actually it's going to give us all remaining lists, from the 5th list all the way to the end. So boom, and that's exactly what it does. It's saying, including 5, so it's actually the 6th list since we're index number 5, but it's actually the 6th list because remember we're counting from 0, but it has the index number 5. So we're starting at index number 5 and then going all the way to the end, and that's exactly what it does. Make note of the row by row method of accessing data. Later you will compare this by accessing data on a column by column basis. Now let's do this. Row by row, and then it has 2 index numbers. So this one's going to say from the first list, or from the second list, because it's index number 1. From the second list, get whatever is at index 1, so which is right here. So it should give us negative 176.58. Boom, and that's exactly what it does. Now it says it's a string because here it has it as a string. But you'll see in NumPy, it doesn't, here it automatically has the integers and floats as a string, but in NumPy it automatically changed them to a float integer, which will be really, really helpful. Now let's extract our column of credit card transactions from our row by row table of Python lists. So let's, let me comment this out. And then for I in row by row, print, so let's see what this does, ready? So for I in row by row, print I to the first. So what it is going to do is it's going to go through this whole thing up here and only print what's in the first index. So only print what's in this column right here. So that's what it's going to do. It's just going to say, hey, whatever has index number 1, print it. And all these have index number 1 right there. So let's see what it does. Bing, and that's exactly what it does. It printed everything with an index number 1. And everything up here has index number 1. Now, let's go to the second one. So here we have a list comprehension, and we assign it to the variable transaction. So it's the same thing, but we just assign it to the variable transactions, and it gives us the exact same thing. Now we're going to do a print transaction, and now we have a list of our transactions assigned to the variable name transactions. Boom, and now it's a list, same thing, but we assigned it to the variable name transactions. Pretty cool stuff. And here's the list of it. So up here, when we didn't do the print function, it just gave us this long line with a lot of empty white space. But down here, let me do this. When we do the print transaction, it gives us a nice clean list. Now let's remove the first item in our list. The original column heading, we want only numbers in our list of transactions. So let me comment this out, boom. So what this does is we're doing transaction.pop. As you can tell from the light blue color, it is a method. And we're saying pop 0. So pop whatever's at index number 0. So here, if we look at the list right here, what's at index number 0 is transaction, since we start counting at index number 0, and it's going to take out transaction and just give us everything else. Or sorry, first it tells us what it took out, so it popped transaction, and then we print transaction. Since it popped the name transaction, it should only give us numbers, and that's exactly what it does. Now, remember, lists don't have to have things in it. Here we have an empty list, and we signed it to the variable name transaction f. And then we have a for loop for I in transaction f, add float I. So it's going to add something. It's going to change I to a float and then add it to this list. The append method is converting each transaction to a float and adding it to the list. Boom. And then we're going to print it. Now let's print out all of our converted and appended credit card transactions. So let's see what it gives us. Let me comment out these two bad boys. Control enter. Boom. And it turns everything into floats, which is pretty cool stuff. So it went through the list, iterated through the list, and changed every element in the list from a string to a float, and then added it to this new list that was empty called transactions f. Now we have a list comprehension, so we did the exact same technique but made it into a list comprehension and saved it to the variable transactions f1. Now let's see what it gives us. Let me comment this out. Boom, boom. Transactions. Okay, so transactions F1, and then we print it out, and it's going to give us in a list the same thing. Boom, and it converted all of our floats from the other list and saved it to the variable transaction F1, but it saved this list of floats to the variable transaction F1. It's pretty cool. Iterated through the list, turned them into floats, and then saved it to a list. Now let's go through this. Let me comment this out so we can see it. The Python map built-in function applies another Python function, in this case float, to all of the items in a sequence, in this case our list of transitions. Consequently, map converts all of our strings into floats. So let's see what it does. So we have transaction F2, transactions F2 equals list, so it's going to turn into a list, map them, so we have map here, so we have 3 functions, each nested inside of each other, float transactions. Okay, so like it says, to all the items in the sequence, in this case, our list transaction converts all of our strings into floats. So that's what it's going to do, all of our strings into floats. And then we're going to print it and see what it does. So boom. And that's exactly what it did. It basically did what happened above, but it was just another way to skin the cat, and it showed us how to change them from strings to floats. It's pretty cool stuff. Now let's go to this cell right here. Let me just comment this out so we can read it first. Our final method of converting our list of transactions into a list of floats will use the numpy Python library. So let's do it. Import numpy as np. Boom, imported it. And then transactions. So we made this variable called transactions, and we said make the transactions into a numpy array. So let's read our original list of transactions into numpy with this single step. So we read it into numpy, boom, and then we're going to call it. Boom, and it's an array. It says it right there. Ignore this D type, but note the data type at the end of the array. It is U7, or it's actually U6, indicating these numbers are currently string Unicode data type. So they're strings, saying U6, U7 says they're strings. And then if we do a type, it should say array. So So let's see the type. It should say numpy array or MP array. Boom, and that's what it does. Numpy array. So that's an array. Pretty cool stuff. And we know it's an array because of this right here. Because of this, A, it says array, and B, because the parentheses and the square brackets. That's a way to indicate that it's an array. Now let's go here. Let me comment this out. Boom, boom. Here, let's convert this once list of string and now array of strings into an array of floats. So here we have transaction F3 and then as type float. So we're converting it into a float. Shift enter, then we're calling it. Boom. And now, as you can see, there's no more of the parentheses, or sorry, of the quotes, and the D type is no longer there, showing that it's not a string. As you can see, yeah, so that just indicates that it's not a string. And then we do D type, which is the numpy way, which is like the numpy equivalent of type, and it shows us what they are. So it's saying D type float 64. So it's saying it's a float. So we converted it into a float. Now, let's condense everything down by feeding the numpy array method our original list comprehension starting at 1 to exclude the column heading. So here, let's see everything. Let me uncomment this. So here we got numpy, and then we made it into a list comprehension, but here it's an array comprehension, but don't worry about that. So we're saying for everything in the first index, in index 1, not the first, but index 1, in that row by row list, that list of strings, turn it into a float. So it's saying in row by row, and then here it's saying everything excluding excluding the very first one. So it's saying from the second one on, because remember we index at 0, so the first element will have the index number 0. So here the second element will have the index number 1, all the way to the end. So everything excluding the first one, turn it into a float. So it's saying getting rid of the heading. And now we did the exact same thing here, but it's just another list comprehension, which is we turned it into a float for everything with the index number 1 for I in row by row. So there's two ways of doing it. And let's call it, boom, it shows us turned it into array. There's strings since there's no quotations and since there's no D type. Boom, D type, it's a float, and then we're going to sort it. It's going to go from descending order, yeah, so from lowest to highest number. Boom, that was pretty cool. Now, with our data extracted from our original list of strings, perform numpy data analysis on this data set of credit card expenses. So here we're going to do, we have our data set right here, our numpy array of transactions, and they're all numbers, it's an array. And we're going to do dot mean. So it's the method dot mean. It's blue. It comes after the dot, comes after the name of the variable, and has the parentheses. That's how we know it's a method. Dot mean is going to give us the mean. So it's going to give us the average number. And these are really cool statistical and analytics tools that NumPy gives us. Now we're going to do dot min. So it's going to show us the lowest number. Boom. The lowest number is negative 176. It's going to show us the highest number, negative 6. And then it's going to show us the standard deviation. So, due to the very large outlier credit card charge of 176, our standard deviation is rather large. And it's negative because it's a charge, so it's taking it out of the bank account. So it's subtracting it from the bank account. So yeah. Now let's perform some data analysis on our data by using the numpy percentile method to find the values at the 50th, 25th, and 75th percentiles. So here we're doing numpy.percentiles transactions 50. So it's saying do the percentiles for this transaction variable at the 50th percentile. Let's see what it gives us. So this is saying that more than 50% of our credit card transactions are less than negative 31, or are more than $31. So the majority of our more than 50% of our transactions costed us more than $31. Here, this is 25 percentile of our mean, so 25% costed less, or costed less than negative 40, or costed more than 40, and then 75% costed less than 9. less than -9 or more than $9. It's a negative because it's subtracting it from the bank account, but really it costed us $9. So it's saying 75% costed $9 or more. And those are just cool little statistical tools that you can use in NumPy. Now, here we're going to do a NumPy column by column approach using the Berkeley Data Science Library. There's no need to convert strings to floats, no need for list comprehensions. Here it's pretty simple. So here, from data science, so from the module data science import table, only a portion of the data science module, BDF equals table, because we had to import table, so we had to put table here. Capital T, remember, be precise. Dot read table is a way of reading data into a table, and then in the parentheses and in quotes, we say the file we want to read. And then we call, and then we assigned all this to the variable BDF, and it gave us this nice little clean table. Now, you have a table of NumPy arrays all sharing the same index to keep all array data in sync and in proper alignment. We'll see what that means in just a second. So here, we're going to do BDF1. So BDF is this table. BDF stands for Berkeley Data Frame. Table, data frame, they're synonyms. With this simple syntax, we can separate out the transaction column into a single array. That's what we're doing. So we're doing 1. So whatever at index 1, remember, this is index 0, index 1, index 2, index 3. Boom. And it's an array, and it gives us all the transaction data. No need for a list comprehension. No need to convert the transactions from string data types to float data types. All this is automatic. So this is what's beautiful about NumPy. NumPy is running under the hood for Berkeley Data Science. So we're doing a type, and it should say NumPy array, and that's exactly what it does. Now here's a very interesting tool, dict BDF. So what it does is to underscore the structure of a Berkeley Data Science table, convert it to a Python dictionary, and notice the following. The Berkeley Data Science table is converted into a dictionary where the column names are dict keys and the dict values are NumPy arrays. So this is very interesting. So a dictionary is basically a list, and instead of a list starting with square brackets, dictionary starts with these curly braces brackets, and for dictionaries they have key value pairs. So a key value pair is basically, here, let me show you. So here we have this whole table turned into a dictionary. Now, like I said, these curly braces here show us that it's a dictionary. So that shows us it's a dictionary. Now here is the key. The name of the column is the key. Okay, and then the value, or what correlates with that key, what correlates with that column, are the values of the column. So the values are here and the keys here. So you can only have one key, but you can have unlimited values for a particular key. And then same here, name of the column, and then the values of that column. Same here, name of the column, values of the column, and they all say D-type, Unicode 10. This is all float, so it doesn't have a D-type, D-type, Unicode 10, D-type, Unicode 34, D-type, Unicode 10. Shows us these are strings. So it's really, really cool, and it's a good way to group our data. So that's what it is. Now, in this lesson, we can see the challenges and complexity of using the CSV reader method for importing data into Python, because the CSV reader method is a row-by-row oriented process. It can involve using techniques such as list comprehension to extract our specific columns of numeric data sets and converting these data sets into either integer or float data types. Using data science libraries like the Berkeley Data Science Library or Pandas makes this process much easier. Both of these libraries use the NumPy library under the hood, and as a result make extracting out columns of numeric data very simple. So it's a very easy to use task. And then here we have a little appendix, but I'll go over that in just a second. You guys don't have to look at that. It's a little bit too complicated. It's some operating system stuff, some Linux stuff, but don't worry. I know this notebook could have seemed a little confusing, but these methods are very, very important. These libraries are insanely important, not just in this class, but in data science and computer science as a whole. The Berkeley Data Science Library is a good training wheels library and a good training wheels module, and the NumPy library is extremely, extremely useful. These NumPy arrays are very useful, and you'll see them all the time, and they'll make your life so easy. I know it seems hard now, but practice, practice, practice. Like I said, your remote desktop is always on, and you're always able to practice. You guys can stay with me to go over the appendix down below, but if not, you guys can go ahead, and I'll see you at the next class. Thank you so much.